Okay, lesson 2.6, add and subtract rational expressions. Here are the two essential questions. You can pause it while you write these down. These are the steps to adding and subtracting two rational expressions. First, we're going to determine the common denominator. Second, we're going to make both denominators common. And third, we are going to add the numerators. Let me show you this problem right here, and then you can write these down. So if you look at 4/5 plus 7/8, these are real numbers. You used to do this back when you're in elementary school and intermediate school, add two fractions like this together. Well, we have to find what is common. What's the least common denominator? You can always times the two denominators together to find a common denominator, and that will work, but it might not be the least common denominator. But if we took the factors of 5, which are just 5, and 8, you can break that into 2 times 2 times 2. You can see that they have no common factors. And so the least common denominator is going to be the two numbers times together. So 5 times 8, which is 40. So now that I've got the common denominator, I look to see, what did I times this 5 by to get 40? Well, I times it by 8. So I have to times the numerator, that 4, by 8 as well. 4 times 8 is 32. And what did I times this 8 by to get 40? Well, I times it by 5. So I got to times the numerator by 5. 5 times 7 is 35. And now that I have a common denominator, I can just add the numerators. 32 plus 35 makes 67 over 40. And you can look to see if those simplify. 67 over 40 can be written as a mixed number, but it does not simplify. So you can pause it right now as you write down the steps to adding, subtracting two rational expressions. Okay, here is our first problem, number 1. If you want to hand out the assignment right now, Mrs. Harris, you can do that. And then we'll work this one together, and then you guys work number 2 by pausing the video and doing it together. So first of all, I look at this, and I want to find a common denominator. Well, if I look at both of the denominators here, they are both 11x. I already have a common denominator. So I don't have to do anything that way. All I have to do, in this case, this is a subtraction problem. All I have to do is go 27 minus 5, which is 22, all over the common denominator, which is 11x. And then I need to see if I can simplify that. I know that 22 is 11 times 2. And so I can see that the 11s cancel out. My answer is 2 over x. So you can go ahead and pause the video and do number 2 together, and then restart the video. Okay, here's problem number 3. You can see that problem number 3 has the same common denominator again, x squared plus 6x plus 9. So all we have to do is add the two numerators. 3x plus 9 equals 3x plus 9. All over the common denominators, x squared plus 6x plus 9. Well, I need to see if I can simplify this. So I need to completely factor the numerator and the denominator. In this case, the top one, I can factor out a common factor of 3. And on the bottom one, I can factor that to be x plus 3 times x plus 3. 3 times 3 is 9, 3 plus 3 is 6. So I have now completely factored that, and I see that there's a common factor of x plus 3 on the top and bottom. So my answer ends up being 3 over x plus 3. And you cannot cancel, remember, those 3's out because the one on the bottom has to be added to the x first before you could cancel it. If that was 3 times x on the bottom, then you could cancel the 3's. But x plus 3 you cannot cancel. So that is the answer. Go ahead and pause the video and do problem number 4. Okay, problem number 5. I can start by, I need to determine the common denominator. I can completely factor these two. Of course, I have x plus 2 in the first denominator. In the second one, I notice that I can factor out a 3. If I do that, I get x plus 2 remaining in the parentheses. Well, these things have something in common, x plus 2, which means if I times the fraction on the right by 3, then I would have a common denominator. So I have to multiply the top and bottom by 3. So I have 3 times 3 is 9 over 3x plus 6. And then the second fraction did not change because it already had the common denominator. And now I'm ready, since I have common denominators, to do the subtraction. 9 minus 2 is 7 over 3x plus 6. Now I already know that the bottom factors to be 3 times x plus 2, but neither one of those will cancel with 7, so I can just leave my answer like this. Or I can leave it as 3 times x plus 2 on the bottom. Either way works. Go ahead and pause it and do number 6. Okay, next problem. I need to determine the common denominator. I can see that on the one on the left, I can factor out a 6. So 6 times x minus 5. And on the one on the right, on the denominator on the right, I can factor out a 3. That leaves me with x minus 5. Well, I can see that x minus 5's are common to both of them, and the 6 breaks down to 2 times 3. So 3 is common to both of them. So the only thing that's missing is on the one on the right, if I multiply the top and bottom, the numerator and the denominator, by 2, I will have 6x minus 30 on the bottom, my common denominator. And so that's what I need to do. And just to let you know, 2 divided by 2 is 1, and you can times anything by 1 and not change the value of it. It just changes what it looks like. So I have 7 over 6x minus 30 on the left, plus I'm going to add to it, I'm going to times these two numbers together. 2 times 2 is 4, and 2 times the 3x minus 15 would be 6x minus 30. So I have my common denominator. If I add 7 plus 4, I get 11 over 6x minus 30. And once again, if I factor out the 6 on the bottom, I have 6 times x minus 5, which does not cancel with the 11. Nothing does, so you can leave the answer like this, or you can leave it in the denominator in factored form. By the way, if you want to rewatch this video at home, or any of the videos, you can do that. Just go to my website. I have posted that in there under the honors class and under instructional videos. You'll find that these two lessons are right there. Go ahead and pause it and do number 8 together. Okay, number 9. Right here, I have the numerator on the left is 2x minus 1, which is totally factored. So we're going to write 2x minus 1. The one on the right, I have a trinomial that needs to be factored. I know that the only way to get 2x squared is to times 2x times x. That would get 2x squared. And the only way to get negative 5 over here is negative 1 times 5, or 1 times negative 5. So I got to determine which ones I need to use right there. I can see that I'm probably going to times the 2 by a positive 5 right there, because I'm going to get 10x. 2x times 5 is 10x. that would leave me with this x down here being times by that -1, which would be 10x times, or x times -1 is -x. And if I add those together, I get 9x. So 2x is going to be times by the 5, so the 5 goes in the opposite binomial, and the -1 goes over here. And so I have, my denominator is 2x minus 1 times x plus 5. Well, I already see that 2x minus 1 is over here, so that's in common. So the thing I'm missing from the one on the left is the x plus 5. So I got to times the top and bottom by x plus 5. If I do that, I'm going to have to FOIL the top. X times x is x squared. X times -3 is -3x. I'm going to do a little calculating up here. 5 times x is 5x, and that -3x plus 5x makes 2x that I can put in down here. And -5 times -3 is -15. All over the common denominator of x plus 5 times 2x minus 1. We're going to leave it in factored form right now. And then over on the right side, I already have the common denominator, so nothing changes on this one. I could have written this in factored form. I should have these two denominators in the same form, but they are the same denominator. Okay, so I'm ready to do my addition here. I'm adding. And so I take and combine like terms is all I'm doing. I have an x squared over here, but no x squared on the right side, so I just have an x squared. I have a 2x plus an x makes 3x. And a -15 plus 5 makes a -10. All over x plus 5 times 2x minus 1, my common denominator. I left it in factored form because I need to factor the top and see if I have any common factors that will cancel. I'm thinking of two numbers I can times together and get -10 and add together and get 3. And I think x plus 5 times x minus 2 will work. And that works out nicely because now we have a common factor of x plus 5 on the top and bottom. So the x plus 5's cancel out, and I get x minus 2 over 2x minus 1. And that is my answer. Remember, you guys can rewind these videos if you need to see anything that you might have missed, and you can watch them at home. Go ahead and do problem number, what was this, 9? So number 10. And then restart the video. Okay, last problem I'm going to do with you, and then you got the rest of homework. X over x minus 7 plus 7 over x plus 7. The denominators are not quite the same. The only way you can get common denominators here is to times x minus 7 times x plus 7. So this one, this side I got to times both sides by the top and bottom by x plus 7. And over here, this side I got to times by x minus 7. So on the top I times x plus 7 times x, and I get x squared plus 7x all over my common denominator. And on the right side, I distribute the 7 to both of these, so I get 7x minus 49 all over x squared, or no, we're going to write that in factored form, all over x plus 7 times x minus 7. So we're ready to combine like terms. Okay, I have an x squared on the top. I have a 7x plus a 7x, which makes a 14x. And I have a minus 49 all over x plus 7 times x minus 7. That looks awfully like a lot like it might factor, but the top doesn't factor because -7 times +7 is a -49, but it adds up to 0. And we have, and that's supposed to be an x right there, 14x. And we don't have the same thing, unless I made a mistake somewhere. If I did, you guys correct me. But I think that's right. And that would be your answer. Okay, you can turn off the video and finish your homework. Remember, you have a daily quiz to do. And then I will be back on Monday.